So today we'll be tackling a stoichiometry practice problem. The reaction of 15.0 grams of C4H9OH, 22.4 grams NaBr, and 32.7 grams H2SO4 yields 17.1 grams C4H9Br in the reaction below. And then you can see the reaction. So our process here, they ask us to A, determine the theoretical yield C4H9Br, right there. B, determine the percent yield of C4H9Br. And then finally, the mass of leftover reactants, if there are any. So, the first thing we did was find the molar masses of that one, that one, that one, and that one.
So here's our molar mass. So C4H9OH molar mass is 74.414. NaBr molar mass is 102.88. And H2SO4's molar mass is 98.12. And C4H9Br's molar mass is 137.03.
And we did that by adding 4 of the molar mass of carbon times 9 times the plus 9 times the carbon times the molar mass of hydrogen, and then the molar mass of oxygen and hydrogen. Alright, so now that we have our molar masses, it's pretty simple from here. So we have 15.0 grams C4H9OH. So what we're trying to find are moles of C4H9Br. So the first thing we're going to do is, since this is grams, we're going to put grams on the bottom, mole on the top. That way, and then we're going to put the molar mass on the bottom. So we're dividing by the molar mass. That'll cancel out the grams, and then we're at moles. Then, because our mole ratio is 1 to 1, we're going to times by our mole ratio, and that'll cancel out the C4H9OH. So that's canceled out, and our grams are canceled out. So now we have 1 mole C4H9Br. So the moles stay, and the C4H9Br stays. And that'll give us 0.20 moles of C4H9Br. Then we do the same thing for all of them. We do our how many grams we're given. We divide by the molar mass times by our mole ratio. This one we get 0.22 moles of C4H9Br. And then we do that also for H2SO4. Divide by the molar mass, cancel out grams, cancel out our H2SO4, leaving us with 0.33 moles C4H9Br. So, this tells us what our limiting reactant is. Our limiting reactant is the one with the lowest amount, and this one is our lowest amount. So,
Here's our theoretical yield. So it says 0.20 mole C4H9Br times 107.03 grams over 1 mole equals 27.406. So by that, our theoretical yield will be 27.406.
Yep, so there's our answer to part A. Now, part B, determine the percent yield of C4H9Br. Percent yield is experimental yield divided by theoretical yield. We just got our theoretical yield, which is 27.406, and we already know our experimental yield from the problem, which tells us that we have 17.1 grams. So we simply take 17.1 divided by 27.406, which gives us 0.624, and then we simply times that by 100. And that gives us the answer to part B. Our percent yield is equivalent to 62.4%.
Despite that, 0.20 mole C4H9Br times 1 mole NaBr over 1 mole C4H9Br, and it becomes the 0.20 mole NaBr times 102.88 grams over 1 mole equals 20.589 NABR. By that, one of the part of answer for number C is 22.4 minus 20.58 equals 1.82 grams. So it is our excess for NABR.
And then finally we have our last one, which is H2SO4. So we go from our 2.20 moles of C4H9Br. We put mole C4H9Br at the bottom. That cancels out that mole, that, and that, which leaves us with our H2SO4. So then we do 0.20 moles times H2SO4. And then we times by the molar mass. We put moles on the bottom, our molar mass at the top. That cancels out our moles, and that leaves us with 19.62 grams of H2SO4. And the problem tells us that we have 32.7 grams of H2SO4. So we take 32.7 minus 19.62, and that gives us 13.08. So the H2SO4 has 13.08 grams of excess. And that's our problem.